Well, good afternoon, everyone. My name is Josephine Giaimo. I'd like to welcome you to the IT Professional Conference afternoon sessions. I'll be talking about non-generative AI and the user experience and sharing my personal field notes. I'm leaving this screen up here for a sec. My email address is listed, my LinkedIn profile link is listed. So please feel free to contact me after the presentation if you would like to have additional conversation. Okay. I do have my own little consulting company, and I've worked as a data scientist as well as a user experience researcher. And of course, I'm a rank and file worker, just like all the other technical people probably in this room. So I do want to touch upon briefly the difference between generative AI and non-generative AI as a context for what I'll be talking about. Because a lot of the attention in the technology conversation today in the public domain is basically around generative AI models. And most of my experiences with non-generative AI, so I wanted to distinguish those. Generative AI models use neural networks, which is a type of AI modeling, to identify patterns and generate new and original content. Now, this is one definition, it's not the only definition out there, but the key difference is that generative AI models do not use supervised learning. They're either non-supervised or self-supervised. And what that basically means is that as the neural network learns based on the data in its training data set, there's no feedback loop. And this is a key distinction. So the non-generative AI models that I'm going to be talking about are supervised neural networks in some cases, or expert systems which don't learn. They're not machine learning examples. I'm going to talk briefly about robotic process automation, which, depending on who you talk to, might not even be considered a type of artificial intelligence. I'm going to talk about supervised data modeling, but not very deeply. On the examples, I'm going to talk about where there is data modeling, it's supervised, and machine learning. So that's the distinction. So I'd like you to sort of play along with me a little bit about this whole idea of what's going on inside the black box. You know, we have inputs, we have something magical that goes on inside the black box, and then we have outputs, right? Do you care what's inside the black box? Maybe we get a show of hands. Do you care what's going on inside the black box? Some people say yes, some people are kind of on the fence, some people no. Okay, I guess it depends on what's in the black box, right? Or what you think might be in there. Okay, so thank you for playing along with me. Okay, how does your thermostat work? This is an example that I like to use. How many of you know how your thermostat actually works? No, like this type of thermostat. Yeah, so I have some hands. Would someone like to explain to me how your thermostat works? How does it work? Yes.
Is that the one with the mercury in it?
Yeah, that's the one with the mercury in it.
3 expands with temperature and then completes a circuit.
Right. Right. So the people I'm going to call the scientific types among us, or the nerds among us, maybe are curious about how the thermostat works. But most people just care about, when I turn it to the right, the temperature goes up. And when I turn it to the left, the temperature goes down, right? That's what most people really care about, right? So I'm going to give another example. Well, how about this? Do you care how it works? Right? We care how it works, right? We care about it, right? How about this one? That's the magic 8-ball. Do we care how it works, right? It just sort of randomly comes up with answers, right? It's as far as we can tell, right? Okay. So this is an exercise in thought, right? Okay, so now I'm going to talk about my examples. When I did my graduate research, I proposed a framework for evaluating the performance of AI and predicting project profits. I used BrainMaker software created by a company called California Scientific. I got this really great data set of asphalt paving data, and I collected data from the company that was willing to share their data with me at the time. And I included numeric data as well as symbolic data. So information like what was the name of the supervisor that day when the work was done, or what was the weather like. So these were my inputs, and I attempted to predict the profitability of asphalt paving based on various input parameters. The results were mixed, but the more important thing, I think, was the fact that I proposed a framework for evaluating the performance of the neural network, and also did a comparable statistical analysis, a regression analysis, as a basis for comparison using a root mean square. And the software I uses something called back propagation. And so this is like what's inside the black box, right? So when you're training the data in a neural network, the error rate is fed backwards through the neural network layers and fine-tunes the weights. Okay, but if you don't really care what's going on inside the black box, you're like, well, okay, that's nice to know, right? Any questions about that? I think maybe it'd be good for me to ask, give you a chance to ask questions about each project as we go along, because, be more challenging to wait to the end. Any questions about that particular project? Yes.
What was on the last slide with that feedback? That's how our neural network works.
You mean, what do you mean by our?
Our, like just our natural one.
Oh, our natural ones. That remains to be seen, because we don't really know. But
does it appear upside maybe it appears that way?
Okay, I'm going to answer your question like this. I'm going to say it may be the case that what we've created when we've created back propagation is an approximation for how we believe a human brain processes information. But we have no idea. We really don't know. We don't know. It's wetware. It's a chemical process. It's wetware. There's synapses. There are neurotransmitters. We really don't know, right? But let's call it a working hypothesis. Fair enough? Okay. All right. Does it sound all right to everyone? Yes.
Last question. Generative AI concept.
General AI concept.
Gen AI.
Gen AI.
Or you mentioned that when it doesn't have the feedback loop. Is that correct understanding? And the non-gen AI is
Sometimes does.
Sometimes have the feedback. So when we train the model and when we deploy the model to some kind of structure, and then we make some calls to get some data. So the feedback loop. Okay? So that's the context of the Gen AI.
Not necessarily, but I will tell you that I have some experience with generative AI, but it's nowhere near as much experience as I have with non-generative AI. And that's why we want to talk. So I can't really speak to how generative AI works as deeply as I can about non-generative AI. But I can tell you that to my understanding that generative AI models work by, like if you're talking about language models, predicting the next word. So there's like this whole mountain of words taken from a variety of sources, all sort of piled together and just sort of plucks the word out and then plucks the next word out. And plucks. That's how I understand it.
So I'm just not clear about what is the feedback. What is the feedback?
There is no feedback loop in generative AI.
Yeah.
That's why you get pictures of 6 fingers on their hands and legal citations that don't exist, but there's no feedback. Okay. Thank you for that question. That was part of why I wanted to come here and talk. Okay, yes.
Would say the supervision is people. Supervising is giving feedback.
Yes. 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 Okay, so everyone good? We'll go on? All right. Okay. In part 2 of our little journey here through my field notes, okay, so this is a very different sort of context here. We used an expert system also provided by a third party. Okay, I'm going to tell you about the business challenge. So, excuse me. So AT&T had this product called Frame Relay that sent large amounts of data through the phone lines. And it was basically a composite of a dozen or two different systems. And it would break a lot. And so the clients were very big. They were like hospitals, banks, publishing houses. And when the line broke down, they got very upset, understandably, right? So it turns out that Frame Relay, being the complex system that it was, that it took expert troubleshooting technicians 2 years to become experts, and they were pulled from wherever they could find them to train them. There was no standardized troubleshooting process that made it more complicated. And because the systems were always being updated and changed, this was in the time of paper documentation. By the time the new set of documentation reached the shelf, it was already obsolete. So into this complicated, complex situation enters the expert system. So what did we do? We found the subject matter experts. If you're going to create an expert system, which is a type of AI, in almost all cases, you need to standardize your process. So we worked with the troubleshooting technicians, the experts, and I helped co-author the system engineering documentation. I conducted cognitive walkthroughs. I sat next to the troubleshooting technicians as they did their work, conducting ethnographic research. They took notes. Here's how they processed the information. And oh, by the way, there was, I conducted pilot training and selected typical troubleshooting scenarios. And there was a metric that they also used. It was called AIR. AIR stands for Analyze, Isolate, and Refer the Trouble. It's basically the amount of time that the troubleshooting ticket is open. Okay, so the time they open it to the time they close it. So what we created was an expert system, a decision support system. It was not probabilistic. It was 100% deterministic, a decision support system that basically walked you through dynamically a series of tests. So it started always at the same point in the network. And if the result of the first test was positive, you branched in one direction. If the result of the test was negative, you branched in a different direction. And so you traverse the tree, analyze, isolate, and refer the trouble. Okay. So what were the results that we got? Of course, we severely decreased the amount of time it took to analyze, isolate, and refer the trouble. We simplified the job design. That meant we reduced the training time from more than 2 years to less than 6 months. So a 75% reduction in the amount of time it took to train expert troubleshooters. And since this actually worked as an intelligent assistant, as I said earlier, we simplified the job design, and they were hired from a bigger labor pool, with people with less skill, because the job was a simpler job. Okay, so like that. Any questions about this particular project? Okay, so this is AI. This is an expert system, deterministic system, no machine learning. Okay. Robotic process automation works with the presentation layer of software. Let's say, for example, you have a bank and a customer comes in, wants to open up a new checking account. There may be forms that need to be filled out. Maybe there are multiple spreadsheets where you have to copy paste the same information as the bank agent from, say, one spreadsheet to another, and do this repeatedly. It can be a tedious and sometimes error-prone process. And what robotic process automation does, it works with the presentation layer, and often can reduce the amount of time it takes to complete and such tasks by 80%, 90%, like that. But there's no what most people would consider artificial intelligence involved in it, even though it sounds like there might be. It's really not. So I wrote a search engine optimization articles for this particular client, and because I had background in AI and machine learning, it was really easy for me to write these articles for them and help promote robotic process automation as a solution. Sometimes people think they need like a sledgehammer to kill a fly, So this is a good example of robotic process automation. Actually is an example of using maybe not using a sledgehammer. You might think you need AI or machine learning, but you really don't. And here in this example, this comes from a UiPath example that I worked with, and I'm not going to run through the YouTube videos now, but you can get copies of the slides and you can look at them at your leisure. But in this example, robotic process automation software opens Microsoft Outlook, opens the PDF invoices, and extracts the data, validates the data, making sure the customer is in SAP, copies the relevant information. It does this all automatically. Typically with these types of systems, if there's an exception or an error, that's when the RPA software stops and maybe sends like a notification or an email to a human being who then deals with the exceptions. So in this example, the robotic process automation software does the logging into the applications, navigates the screens, toggles between the applications, converts the data into the proper format, and extracts the data. So of course, does a lot of these repetitive routine tasks in a fraction of a second. Any questions about the robotic process automation example? Okay, I'm going to keep going. Thank you. I did some ethnographic research for a company that is in the healthcare IT area. This particular company works with insurance companies to contact patients, clients of the health insurance company when they've had like a major medical event and they want to maybe put possibly advanced care directives in place and like that. But it's really interesting because the people who perform this work usually are clinical social workers, licensed social workers, and they wind up having maybe a half a dozen phone calls over a period of 2 months with the clients, with the patients. And the interesting thing is that these conversations as a trajectory follow a general pattern. So the long-term goal for this client was to perhaps be able to create AI-assisted software that would be able to support the social workers and maybe even interact with the patients themselves. So this is a kind of a long-term goal. I performed day in the life research. So I sat in the cubicles with the social workers and listened to their side of the conversations. They have specific objectives at each milestone in the 6 phone call conversation. But it's fascinating because not all of the outcomes are the same, but the conversations tend to follow a pattern. And probably I'll leave it at that. Any questions about this example? Yes.
This is healthcare IT.
Yes.
Is it useful in the med beds that they're now coming out with medical beds?
Can you say a little bit about that?
What's that?
Can you say a little more about that?
Well, as I understand it, maybe they're starting with the military. When they're in a med bed, they use AI software to analyze what's wrong with them and provide medical solutions. And I was wondering if this could benefit using in med beds.
It's certainly possible. I don't really know how smart the med bed is, but I could imagine it being smart enough that it could provide some supplementary information. But, giving it the benefit of the doubt.
Right, this is all new, a new thing. for-
Yeah. Again, so part of what I'm thinking is, now I'm thinking, what's inside the black box, right?
Right.
Right? I don't know, but maybe there's something there. All right, ready for part 5? Okay. Oh, yes. This was a great project. Another healthcare IT product. Okay, so this healthcare product found trends and anomalies or errors in clinical research data. You used big data in the cloud, used machine learning. It for every pair of variables in the entire clinical research data set, it did a pairwise correlation, and it performed these comparisons in a matter of hours as opposed to, say, weeks, right? So because of my background in machine learning, I was able to write these 100 articles, which were basically how to use the software. So how does a clinical researcher doing research on a new drug use this software? Maybe they're interested in comparing certain variables. There were lots of scatter plots that were generated. And it was very interesting. I want to point out that it's really important to learn about different disciplines, even ones that are not within your comfort zone. I'm a big fan of interdisciplinary work. So if it really is a good idea to learn about machine learning if you can, and I'm going to be talking more about that later. So this product, I worked on this product in 2015, and I found out during the pandemic, much to my happiness, that it was used by Moderna to help develop the Moderna vaccine. So I felt really good about that. The part of the product I worked on was called Centralized Statistical Analytics. As part of a bigger product called Detect. As I mentioned, it runs big data analytics. There was a machine learning algorithm that is proprietary that was used to generate the analytics. Yes, processes up to 1 million data points in less than an hour. So I just, bear with me here. These are, if you care about what's inside the box, you might care about some of these parameters. Yes.
On the previous slides,
Yes.
certainly clinicians could adjust the algorithm, but
Yeah, clinicians can adjust the learning parameters, but probably won't. Well, because it goes back to what's inside the black box, right? When this software is given to the clinicians for use, there's a set of default parameters. And kind of like a recipe, unless you know what you're doing, you probably don't want to change the amount of salt in your baked good, or the default parameters are given to the clinicians, unless they have a background in biostatistics or machine learning, they're probably not going to even know what to change them to, right? Right? Make sense? Oh. So here, I just bear with me here. Here are some of the learning parameters that, if you care about what's in the black box, you probably care about some of these things. But if this is not your area, or you're willing to say, okay, that's in the black box, I'm not going to touch it. I don't know what I would do with it. Here's some of the parameters. So just to give you a sense of the kinds of things we're talking about, right? Okay, so I call this calculus free because I know a lot of people are like, well, I'd like to train a neural network to do something, but do I really have to take differential equations to do that? No, you don't. Okay. And I recommend that you consider building your own no-code AI implementation. It's really not that hard to do. So, and I include here some no-code AI options. You have access to the slides. Okay, and I think that's it for me. Are there any questions? Yes.
How do you get to the Amazon SageMaker? Amazon SageMaker.
I would just Google that. Yeah, I would just Google that. These have been around for, I think, at least 2 years now. But I think it's really valuable experience because we were talking about this idea earlier that, I talk to people. I mean, it's great to have ideas. Neural networks can be used to classify things, to generalize, and to predict things, right? So, you want to imagine applications where you could classify, generalize, or predict things. I'm like all in favor of that. Get data that is unlikely in some domains to offer valid results, and try creating a model. I invite people to do that because I think that sometimes we can be pleasantly surprised. But what I more often find is the case when I talk to people about AI is that because they don't have any firsthand experience in building a model, their ideas are maybe not as realistic as they might otherwise be. So I recommend that you consider building a model. When I first started working with neural networks, memory was still on the expensive side. It was hard to find a big enough data set with enough of the right kind of data. And now, of course, all that's changed. Now we have, like, for example, one area that I think is really possible interest, I'm going to share with you, has to do with, and again, in the medical field, there are lots of opportunities in the medical field to do this kind of work. Let's say someone has a transplanted organ, right? And so there's a possibility of the organ being rejected, right? So I understand there are 7 different drug protocols that doctors can choose from to give a person, but how do they decide which one to give the person, right? So you choose the wrong one, maybe, the person risks rejection of the organ. So we don't know what the inputs are. We don't know what the parameters are. Is it blood type related? What is it related to? We have no idea, right? But so you have hospitals, and I know about this firsthand. There are hospitals that were saving this type of data on organ transplants on magnetic tapes in the basement, and they were actually throwing the data away because they didn't know what to do with it. So we kind of have the opposite problem now, where now we have an explosion of data. But I still think that sometimes people don't know what to do with the data, but now at least we have some no-code AI options. And, I invite you to give it a try. Yes, in the back.
There's any war stories about where people have tried to implement generative AI because it's fashionable, and maybe say, come in and say, well, rip all this stuff out with non-generative AI and get you there quicker or cheaper.
I don't have any stories like that. Okay, so I hope this provided value to you, and I hope you enjoy the rest of your time at the conference.
Thank you. Thank you. Thanks.